Welcome to our last chapter, chapter 13 on time series. This is the last topic for our semester, so way to go. I'm going to be keeping things very high level here, just in the interest of time. You're not going to have a lab on this topic that you'll need to turn in, but as a reminder, there is a lab that I would encourage you to look at, to work through. I'll post solutions on those on time series. Now, the time series that we think of the most in economics is gross domestic product. And so we can see in this chart how it has changed over the years, and we could potentially think of doing regression analysis where gross domestic product is our dependent variable. We have some explanatory variables, and I've thrown in a linear time trend. So every year it increases by a certain amount. We also could think of, instead, we've done transformations before where we're looking at the log of GDP as our y variable. This looks the same, but it's not changing by a certain amount every year, it's changing by a certain percentage every year. And we have our explanatory variable x here. Now the subset is no longer I. To denote the fact that we're using a time series, we use a t subscript instead. Here's another time series data. This is retail sales, national, excluding food services, and this you can see as it moves over time in the mid-90s to the mid-2000s. Normally in a class setting, I'd ask you to sit and think and tell me what you notice. And so if you want to pause it and take some notes on this, go ahead. But what I normally am looking for from students is the fact that there's a trend that's going in an upward direction. This looks to be more linear. That may just be a fact that we're looking at a smaller time frame than we were looking at in our previous display. The other thing that is very evident from this time series is there's some seasonality going on, and that happens around the holidays. You see, it looks almost like a heartbeat with these spikes and the dips. That is a pattern that we see in this retail sales data. We could again look at a regression output, but what I want to emphasize is how, even though this looks like things that we have seen before, it is not the same. So I'm going to show you what we've seen before. This is a scatter plot of x and y. This was sort of made up data here with noise. It looks similar to a scatter plot of time and y. But what's very, very different now is the fact that we're having this temporal ordering. It's not being ordered by simply some x variable, but there's an order in time that connects our observations together. Before, we did not have that connection in our variables. We had their own x's, their own y's. Now the y is the same and it's changing over time, but it's the same y. And so what I want you to recognize is that this isn't just some x variable, it's time. And these aren't just different observations, they're the same thing moving through time and connected to each other. And it's that interconnectedness among these observations that is very different in time series data. Let's look through one example of things that look like they might correlate when we plot them on a graph. So if this was a normal x variable and we saw this type of correlation, we might be excited. But because this is time series, I'm going to show the difficulty with that. So we're looking at federal debt in blue on our left axis here, and money stock in red in our right axis. So it looks like there might be some relation. If we wanted to investigate this further, maybe we could think through not just looking at the levels, because the levels of both are increasing, the levels of a lot of things are increasing, but maybe we actually look at percent changes. So in this second graph, what we're looking at is year over year changes as a percent. It's a little bit harder to see whether or not there is a connection between these two. Sometimes it looks like they're moving in the same way, sometimes it looks like they're moving in opposite directions, it's hard to see. This is the same or opposite, and this looks to be the same. One other way to disentangle when we have a time series is to divide by something separate, but that also is moving across time. The most common thing that we see used is to divide by gross domestic product as something that is normalizing these values. And so both of these series are being divided by gross domestic product, and this takes out some of the variability that is common to all of these different indices over time. And so we're just seeing how it changes compared to gross domestic product. And in this view, we see that these two things, federal debt and money stock, are not particularly looking like they are connected. So what we're going to do in this topic in this series is worry about these types of spurious correlations and how to deal with them. Because anything that has this temporal ordering and is changing over time is a potential candidate for spurious correlations. There is a very amusing website that you can go to, it's linked to in the description of this video, that has a lot of spurious correlations over time. For instance, the number of films that Nicolas Cage appears in a given year is very correlated with the number of people who drowned by falling into a pool. Do we think there's any sort of causal relationship there? Probably not. And so that's why we have to be careful here. Here's another example. The number of per capita consumption of eggs in the US is correlated very strongly with the number of drivers killed in non-collision transport accidents. And finally, the number of winning words in the spelling bee is correlated here with the number of people killed by venomous spiders. So clearly we need to use fewer words in the spelling bee to save lives. That would sort of be the policy question. So like I've emphasized, the big difference here is that time series data has a temporal ordering, unlike cross-sectional data. Before, any observations, y1 was unrelated to y2 in the same way that it was unrelated to y90. There wasn't sort of any sort of connection between our outcomes. But now there's this ordering where y1 is close to and potentially related to y sub 2. Time period 1 is related to time period 2 in a way that is not related to time period 90. We no longer have a random sample of individuals. Instead, what we're looking at is a process, a stochastic process over time and how that develops. So what we're going to do in this unit, we're only going to scratch the surface and very briefly touch on time series analysis here. You could take multiple courses on time series analysis. It's a complex topic, but we're just going to scratch the topic, scratch the surface of the topic. But I want to emphasize 5 things in this unit. The first is what I'm emphasizing here, that this is fundamentally different from cross-sectional analysis. We're not just picking unrelated individuals and looking at them, we're looking at how a process changes over time. We're looking at the same thing again and again and again. It's very different. The next thing we'll talk about is an idea called autocorrelation or serial correlation. It's this idea that the error term may persist over time. So you might have persistence in that, all right, say other stuff that is impacting GDP yesterday is still happening the next year. It stays around. It's impacting GDP today as well. There's persistence in the error term, and that's going to impact our ability to calculate our standard errors. We're also going to discuss dynamic models, where not just the error term is sticking around, but the previous values of y itself are going to determine what y is in this case. These dynamic models where there's actually stickiness in your outcome. And the final thing we'll talk about is stationarity, or if the impacts aren't sort of fading, if y changes and now that's your new baseline, if there's changes in our actual distribution over time, the average and things like that changes, then that presents difficult problems for econometrics as well, which we'll only briefly be able to touch on. The point of this that I want you to walk away with is not that you're going to be how to fix every problem in time series, but I want you to sort of recognize the difficulties in doing time series analysis, and that it is difficult and hard. Thanks for watching. I hope you're doing well, and I hope to interact with you soon. Take care.